So, hello, welcome to the NPTEL live sessions for the course Engineering Graphics and Design. So, introducing myself, I am Vikram Balaji. I am a research scholar from the Department of Mechanical Engineering at the Indian Institute of Technology, Madras. The instructors for this course are Professor Dr. Sunil Kale and Professor Dr. Naresh Datla from the Indian Institute of Technology, Delhi. So, this is a sample recording for the live sessions meant for the sake of testing. So, let us now proceed. So, here are the details of the live sessions which I have mentioned. So, in total there will be around 12 live sessions which will span for 12 weeks. So, each live session will be pertaining to the particular week lectures. So, the session will be every Friday evening from 7 to 8 p.m. For a duration of 1 hour. So, all these sessions will be held in Google Meet, the link of which I have provided here. So, here it is meet.google.com/gwqkkuvrqn, which is the Google Meet link. So, in case if there are people who are not able to attend this Google Meet session, so not to worry, the recorded video will be uploaded to YouTube in this channel. So, the URL of the channel I have provided below. So, what this session will be? The session will actually involve a recap of the concept which learnt in the corresponding week's lecture, followed by solving of some sample assignment questions. So, other than this, there will be also some discussion of doubts. So, many students who might have this doubt whether this live sessions are compulsory to attend or not. So, the thing is that the attendance is encouraged, but it is not mandatory. So, it will solely depends on your self interest as far as the live sessions are concerned. So, these are the details of the live sessions which I have provided. So, let us now proceed. Okay. So, the course is Engineering Graphics and Design. So, the course title involves the word graphics. So, the question automatically arises, what is graphics? So, there is a picture over here. So, this is looks like a cave painting. So, this is actually our country India's oldest cave painting, which is datable to around 10,000 BCE as per the archaeologists and historians. So, this is found actually in the state of Madhya Pradesh in our country. So, this cave painting is called the Bhimbetka cave painting. You can actually look this up in the Google. So, this is one picture. So, now here there is what you can call a pie chart which shows the crude steel production around the world in terms of percentage. So, different countries how far they contribute to the steel production. So, here you can see China is the maximum at 51%, our country India is listed at 6%. So, this is also some sort of a picture. So, this is a third picture. This picture shows the illustration of the water cycle about which we might have learnt in our primary classes. So, there is sea water, there are many water sources like ponds, lakes, rivers, sea, etc. So, from there the water evaporates and it rises up in the air, and then at the atmosphere it gets condensed and it forms clouds. These clouds then give us rain through the precipitation, and this rainwater is then collected by the different water sources present in the earth, and then again this cycle keeps on continuing. So, this is also a picture. The fourth one, this is a painting of the world famous the Jagannath temple, which is located at Puri in the state of Odisha in India. So, this you might know, this is a character called Tom in the famous cartoon series which is called Tom and Jerry. So, this is the current political map of our country. So, we can see the different states and the union territories, how the borders and all. So, this seems to be a technical drawing of some sort. So, here there is shown gear linkage. you can see, so the various parts are shown, the various sizes are indicated, and so this seems to be a technical drawing of the gear linkage. So let me slightly move my screen. I'll keep it probably here. Okay. So here you can see, this is the image of a rocket launch, probably NASA's this thing. This is an image of a rocket launch. So what I have shown is, I have shown different kind of pictures over here. So all these actually you can call it as a graphics. So now the question automatically arises, what is graphics? So we have seen a collection of pictures. Again move back to the screen to the bottom. So we have seen a collection of pictures over here. So this also question, what is graphics? So the word graphic originates from the Latin word graphicus or the Greek word graphikos, which means belonging to painting or drawing. So this is how the word graphics originates. The definition, if you see, it is here shown here. A graphic is an image or a visual representation on some surface. It could be any surface, like it could be a wall, it could be a canvas, it could be screen, it could be paper, or it could be on a stone. So its purpose is, it's meant to inform, illustrate, or entertain. So what are the pictures? The 8 different pictures which is seen in the previous example all belong to the umbrella called graphics. So particularly engineering graphics. So our course deals with engineering graphics. So as seen previously, the term graphics includes a wide collection of images ranging from photographs, drawings, line arts, mathematical graphs, line graphs, charts, diagrams, typography, numbers, symbols, geometrical design, maps, engineering drawings, etc. All these constitute what is called as graphics. So engineering drawing is a narrow subset under the broad umbrella of graphics. So if you ask what is engineering drawing, so an engineering drawing is a type of technical drawing that is used to convey information about an object. So engineering graphics refers to the creation of engineering drawings. So we shall move to the next. Okay, you see there are 2 pictures over here. So one picture, it seems to be a beautiful picture of probably a sunrise. Sun is seems to come rise up from the horizon to the upward direction, and you can see some grass fields are there, and some trees and some shrubs are all there. So this is one picture. The second picture, you can see there is a part. So this part is usually called as flange. Flanges are usually used for coupling 2 different objects. For example, you can be used to couple 2 pipes, or you can couple 2 you can if you have seen in the our railways how the 2 different compartments are coupled together, they also use some kind of what is called as flange. So this is that part. So you can see there are different views of the flange being represented, and they show what are all the parts in the flange, and they show what the sizes are indicated. So there seems to be some difference between the 2 pictures shown here. So both can be constituted as graphics, but only one of them is engineering drawing. And as you might know, the second picture is what we constitutes an engineering drawing. The first picture does not constitute an engineering drawing. So the question automatically arises, what constitutes an engineering drawing? So the characteristics of an engineering drawing are shown here. First of all, they need to be clear, neat, and easy to understand. Okay, fine, that is a given. And the second and very important point is, they should be governed by a set of drawing standards. So the 2 pictures we saw here, the first picture need not be necessarily governed by a set of standards. So whatever is the viewed by the person, so you just click the photograph, and then this photo is occurs as a picture. So there is not necessarily any standard associated with it. However, if you see the second picture, there seems to be a different kind of views are there, and these views are oriented in a particular manner, and the sizes are indicated in a particular manner, and there seems to be some details which are given. So this second picture seems to follow a definite standard. So this standard is very important as far as engineering drawing is concerned. And the third point is, it has a complete geometrical product specification. And the fourth and fifth point, which are also important in case of an engineering drawing, the details of the geometry, the shape of the object, which is represented as a view. So, how the object will look when it is viewed from various angles. The next point is the dimensions. The size of the object is captured in some accepted unit. It could be any unit. So, that unit is also will be governed by a standard to be followed. The next point is that it should be 100% correct. There should be no ambiguity or mistake of any sort. And the last and important point is that it has the ability to be interpreted by others in exactly the same manner as intended by the originator. Okay, so if you go into this picture itself, first picture itself, you can ask the question: is it necessarily sunrise? It could be sunset also, because both sunrise and sunset involves in both the sunrise and sunset. What happens, what we view is that the sun seems to pass through the horizon. That is what we view, and that is being picturized. So, unless we know the direction of the place which is associated in that picture, we do not know whether it could be a sunrise or a sunset. But there is no such ambiguity in the engineering drawing. So, every part has a particular detail and a particular size, and they are indicated as it is. So, that is one big difference between a normal graphic and an engineering graphic. Okay. So, let us move to the next. So, yes, engineering drawing is the universal language of engineers. This is a very important point, because the drawing prepared in one country will be utilized in any other country irrespective of the language spoken. So, we are in India. So, we prepare an engineering drawing maybe and send it to some person who is in European country. So, he should also interpret the drawing in the same way as we intend to show in the drawing. So, that is very important part. Okay. So, we saw here that the engineering drawings are governed by a set of drawing standards. So, what are these standards? So, the commonly used standards is the IS, which is the Indian standards, and ISO is the International Standards Organization. So, these both the Indian standard and International Standard Organization, both standards are more or less harmonized. So, what you find in IS, you will also find in ISO and vice versa. So, there are different things that need to be standardized. So, first thing is the sheet size. So, here there is a depiction of the various sheet sizes. So, there is a series sheet and there is a B series sheet, and we have the various dimensions which are indicated over here for the different sizes of sheets. So, this A0 is the big sheet which is shown here. So, let me make my pointer. Yes. So, this is the sheet A0. So, as indicated here, it has 841 mm of length and 1189 mm of height. So, this A0 sheet, if you fold it along the width direction, so you get what you called as A1, which is the half, which is the A0 sheet folded in half. So, we get A1. Again, A1, if you fold it in the length direction, so you get A2. Similarly, from one size of sheet, you get the other size of sheet merely by folding it in the corresponding direction. So, same for the B. So, these are the standard sheet sizes which are used in engineering drawing. So, next comes the scaling. So, why we need scaling? So, the objects which we are supposed to represent in engineering drawing, there may be of a wide variety of sizes. So, it may start from a simple small screw in a assembly to a very big a thermal power plant or a nuclear power plant or representation. So, you see that the array of objects is from even the microscopic level to the super microscopic level. So, we need different kind of scales to represent the drawings properly on the sheets, the sheet sizes which we have mentioned earlier. So, the standard which is followed for scaling is in IS 10713 1983 or ISO 5455 of 1979. The full size means that a scale with a ratio of 1:1, which means that a 1 unit of drawing exactly corresponds to the 1 unit of the real size of the object. So in the case of reduction scale, you can see that it is a scale where the ratio is smaller than 1:1, which means for example we have 1:20, which means that 1 unit of drawing corresponds to 20 units for the real object. There is a third type called the enlargement scale. This is a scale where the ratio is larger than 1:1. For example, 10:1 means 10 units on drawing corresponds to the 1 unit for the real object. So the recommended scales for use in an engineering drawing are shown here. So we have a set of enlargement scales. So it starts from 2:1 and then goes to 5:1, and then the multiples. So then 10:1. So the 2 multiples of 10 becomes 20, then 5 multiple of 10 becomes 50. So these are this thing. So full size is 1:1. So reduction size, it starts from 1:2, then goes from 1:5, then 1:10. Then again the multiples of 10, multiples in terms of 10, if you see, then 2 becomes 20, then 5 becomes 50, 10 becomes 100, then again 20 becomes 200, and so on. We can see up to 1:10,000. So there may arise a situation where the scales which are given here will still not be enough to represent fully the object in the engineering drawing. So in such a cases, you can go beyond this 1:10,000, or you can go beyond 50:1 just by multiplying with the integral powers of 10. So in very exceptional cases where the recommended scales cannot be applied, so some sort of an intermediate scale can be used. So we will look into this scaling in detail in the subsequent sessions. So similar to scaling, there are some standards for lettering. So you can see how the letters are to be lettering is to be done, and what are the dimensions of it, what is the gap between 2 capital letters, what is the gap between 2 small letters, what is the gap between one word and another. All those are you can see in this standard which is mentioned over here. So similar to the lettering standard, we have the standards which denotes a different types of line type or style names. For example, we have a continuous line, we have a dashed line, we have dash space line, and like this we have so many types of line which are used for different purposes, the details of which we will be seeing in the subsequent sessions also. So this standard which mentioned here, it shows the what type of line and what are its applications. So here we saw what are the different types of lines which are there, and in this standard you can see what are the applications of the each type of line. So this is also one particular standard. So likewise there are many standards for many engineering drawing applications. So we will see that later. So now what are all the steps in creating an engineering drawing? So the first and foremost step is, first of all, you have to visualize an object or an idea or an innovation as a picture in mind. So if it is an existing object, you have to be able to visualize it. Maybe it could be a cylindrical object, it could be a spherical object, it could be a conical object, or it could be of any shape, complex shapes. It could be 2-dimensional object, it could be a 1-dimensional object, it could be just a point. There are many such cases. So first step is to visualize the object or idea or the innovation. If it is not an existing object, then you suppose you want to create an object of your own. So what shape it should be, whether it will be combination of different shapes or many such cases. So whatever it is, we have to first visualize a picture of it in the mind. The second step is to express that visualization in the form of a sketch. This sketch could be done on a pen paper, or it could be done on nowadays people use computer softwares to do sketching. There are some CAD packages where you can physically model the 3-dimensional object and then generate the different sketches. So there are many options. The third point is to add a size related information. So this is what we call in engineering drawing terms as a dimensioning. So the next point is to represent as a professional drawing by following certain conventions and standards. Okay. So in engineering drawing, we generally do not go into details of texture and color. All drawings are in default in black and white. Maybe in some cases we would mention like what texture or what color the product will be, but it is not explicitly shown in the drawing. in the sense if an object is yellow in color, it is not painted as yellow. Maybe we will just draw the drawing, and in some place we will place a note to show that this object is yellow in color in real life, something like that. We do not color exactly. Same for the texture. So typical engineering drawing is used for many years or decades, spanning across generations of engineers. Suppose some the drawing of an aircraft is there, the aircraft wingspan, the drawing of a wing is there. So that same wing, if it is manufactured 10 years later, maybe the people who worked on the 10 years earlier may not be working 10 years later. So a different set of people or engineers will be working on the same aircraft, but the drawing will be more or less same. Maybe some kind of new additions or new improvements can be done, but the files will be maintained. So a typical engineering drawing is used for many years, spanning across generation of engineers. So the first and most important step in engineering drawing is the ability to visualize. So this is very important. So this is the first step before creating any engineering. You have to be able to visualize. So when it comes to visualization, visualization is the ability to observe or conceive an object and make graphical representation in the form of a sketch. So first you have an object, you are observing something, either you are observing an existing object or you are in the sense thinking about a new object, how it could be, or various kind of imaginations are there. So all that you have to be able to observe or conceive, and next you have to be able to make a rough graphical representation in the form of a sketch. So this is the first step in any engineering graphics, this thing. So visualization. So visualization is integral to the process of engineering. Not only in engineering graphics, you can see even in the non-engineering domains, the visualization is very important. So an object can be visualized by looking at it from multiple directions to generate various number of views. The question automatically arises, how many views are required to completely express the object in sketches? So let us say I have a cylinder. So the cylinder, when you look at in some angle, it will look in some way. If you look at the top, from the top it will look some other way. If it will look from the side, it looks some other way. So how many such views are required to completely express the object? Suppose if you have 3 views, with these 3 views will you be able to say that it is a cylinder, or whether these 3 views are not required, I need some other view to confirm whether it is a cylinder or not. So automatically such question arises. Also another question arises is, what are the different types or methods of views, and how can they be sketched onto a flat surface? That flat surface could be a paper or a computer screen or many such examples. So what are the different types or methods of views? So there are infinitely many views possible. Even among that, there are some classifications, like this viewing in this particular is called as one particular way of viewing. There will be many such classifications. So what are those classifications? How can they be represented on a flat surface? So this question automatically arises. So these things we will be discussing in subsequent live sessions. So we will be touching upon these concepts. So just before we end this sample session, I just want to show a sample question of that can demonstrate the ability to visualize. So for example, so we have 2 questions here. So this is called spatial visualization. So you can see this kind of question arises in many tests that examine the IQ of IQ, or you can say it occurs in some aptitude test also, such kind of questions. So this is these questions are meant for the test the ability to visualize. So you have a kind of a 2-dimensional cutout over here. So some squares are painted in blue color and some are not painted. So we want to fold these squares in such a manner to generate a cuboid. So this is generally like we can observe in cardboard boxes, where a 3-dimensional object is created by folding the cardboard along various edges and then closing them to get a three-dimensional object. You can see in a typical in our pizza delivery box, you can see that it is the, when you unfold the pizza delivery box, it is essentially a two-dimensional object with made out of cardboard. But when you fold it along particular directions and assemble it, you can find that it becomes a three-dimensional object which can store pizzas, so in which the pizzas are delivered. So similarly, you see that there is a two-dimensional cutout which is then folded along the required edges to get a cube like this. So if this cutout is folded, so what is the correct option of the final cube which we will get by folding? So we will just see here. So suppose you say this central box is the base and you fold all other squares around this central box. So let us say that you fold this to the, this becomes a right surface, this fold becomes the left surface, this becomes the back surface, and this becomes the front surface, and this down square becomes the top surface. So if you see in that case, which all surfaces will be colored? So your right side and left side will be colored and your top will be colored, but your front and back will be not colored. So if you see the options here, if you look at option A, it gives the impression as if the top surface, the right surface and the front surface all are colored, which is definitely not the case. If you see option C, only the top is colored, but we have seen that our right and left are also colored. So this does not seem to be the correct option either. So if you see in this D option, it shows an impression as if the front side is colored, but top side and right side are not colored. So again, the right side is definitely colored, so this also does not seem to be the option. So if you look option B, you can see that the front side is not colored, but the right side and the top side are colored. So if you fold this, you can see that this square corresponds to the front surface. So there is a pointer, laser, yes, laser pointer, yes, okay. So I am putting in this surface. So this surface becomes the front one. The front one is not colored, while this surface, this square becomes the side surface, right side surface. This is colored, and the left side is also colored, and the top is also colored. So the left is not visible, but among the options, the B seems to be the more appropriate option for this question. So you can say that it is a B option is more relevant in this case. So this is one question that tests your ability to visualize. So if you fold 2D cutout into 3D, so what is the correct option? So this is one such thing. So another is called as a rotation test. Okay, so you have a three-dimensional object, which is, you can say, a cuboid, and a small protrusion which is like in a cubic shape. So this is rotated to get this. So in a similar fashion, if this object is rotated, which will be the correct option? Okay, so first of all we need to evaluate how this object is rotated so that you get this. So this seems to be a rotation in the, let me introduce in a pen. So this seems to be rotated like this, so like this. So you can see this square comes to the top and this is rotated by 90 degree. So this rotation is like this. So similarly, if you rotate this object, if you see that this L will become how you can say, it will be like this. This L becomes like this. So from this existing option, we can see that D seems to be the correct option. So you can see from the shape of the L. So how when the L is rotated in a three-dimensional, how it will be. So this kind of thing expresses the ability to visualize how an object, how you can view an object, how the view of the object is changed when the object is rotated. So many such things. So with this I conclude this sample session. So from the, as I have said earlier, the main sessions will start at Friday. The first session will be on 29th July. So we will see from 29. So we will see further concepts of visualization and many such things. So this is just a sample lecture. So with this I conclude this. So thank you.